Um, Good afternoon, all of you. Well, actually, in today's session, we are going to do properties of triangles. Now, the thing is that due to some reason, the stream has got a bit delayed today, the start of the stream. So, what I have decided is that I'll tell you all the formulas, and then, depending on the availability of time, we'll do a few questions. But what I'll do is I'll tell you all the formulas of this chapter. So the very first formula of this chapter, see, we already know that area of a triangle is root over s into s minus a into s minus b into s minus c. That is a formula which is pretty well known. By the way, we will discuss the proof of this formula also. But the other famous formula of area of a triangle is the famous half base into height. So half base is BC, height is AD. So half BC into AD. Now look at this diagram. This is capital A. So this side will be small a. So BC will be small a. And AD, it will be small c into sine B. So AD will be small c into sine B. So the area of the triangle will be half AC sine B. Right? So area of the triangle is half AC sine B. So this is the main formula for area of a triangle, the one which is known as the Heron's formula. The half base into height is there, but this is another one, and in this chapter this formula will be used more often. Right? So suppose there is a triangle ABC and it is being circumscribed by a circle, and there is a point D on the circumference. So you join B to D and C to D. So these two angles are both A, and BOD is the diameter, so radius. So sine A will be, because you know angle in a semicircle is right angle, so this angle will be 90. So sine A will be base by hypotenuse, so A by 2R. So this is actually called the sine rule. This is actually called the sine rule. A by sine A equal to B by sine B equal to C by sine C equal to 2R. Okay, this is called the sine rule. A by sine A equal to B by sine B. So we have proved that A by sine A is 2R. That we have proved. Charge open. Okay. So A by sin A is 2r, but the rule is A by sin A equal to B by sin B equal to C by sin C equal to 2r. So this is called the sine rule. Okay, then we come to the cosine rule. So suppose there is a triangle ABC, this side is A, this side is B, this side is C, and I can say BD is BC minus CD. So BD will be C cos B, BC is A, and CD will be B cos C. So okay, actually all of you, for cosine rule the derivation is something different. First you take a Pythagoras. AC square is AD square plus CD square, then AC square is B square, AD you write it as C sine B, CD you write it as A minus BD, so that is A minus C cos B. So B square is C square sine square B plus A minus C cos B whole square. So B square is C square sin square B plus A square minus 2AC cos B plus C square cos square B. So ultimately cos B will be A square plus C square minus B square by 2AC. So this is called the cosine rule, right? This is called the cosine rule. So cos B is A square plus C square minus B square by 2AC. So similarly, if you are asked to write cos A, it will be B square plus C square minus A square by 2BC. If you are asked to write cos C, A square plus B square minus C square by 2AB. Okay, so these are all different versions of cosine rule. Like I am starting with any one, cos B, and then I am showing you the others. So this is the cosine rule. Okay, then if you look at this bottom side of the triangle A, so A is BD plus CD. So we can say C cos B plus B cos C. So this is another formula. A is equal to C cos B plus B cos C. So similarly we can have B is equal to A cos C plus C cos A. So you can have equivalent formulas. You can have C is equal to A cos B plus B cos A. So you can have equivalent formulas for this one. Okay, then okay, the next one is called Napier's formula. B minus C by B plus C is sin B minus sin C by sin B plus sin C. So it's 2 cos B plus C by 2 sin B minus C by 2. 2 sin B plus C by 2 cos B minus C by 2. So tan B minus C by 2 is equal to tan B plus C by 2 into B minus C by B plus C. Now B plus C by 2 is so cot A by 2 is B minus C by B plus C. Is equal to tan B minus C by 2, right? So this is called Napier's formula. Once again, if you start with B minus C by B plus C and keep on simplifying, then you will get tan B plus C by 2 into B minus C by B plus C is tan B minus C by 2. So tan B plus C by 2 is cot A by 2. So cot A by 2 into B minus C by B plus C is tan B minus C by 2. Now you can have equivalent formulas like this is if you start with B and C, if you start with C and A, if you start with A and B. So you can have equivalent formulas. So this is all known as Napier's formulas. Okay, now if you go back to the cosine rule, cos A is b square plus c square minus a square by 2bc. So we can write 2 cos square a by 2 minus 1 is b square plus c square minus a square by 2bc. So we can write 2 cos square a by 2 is 1 plus b square plus c square minus a square by 2bc. So that is b plus c whole square minus a square by 2bc. So cos a by 2 is root over of b plus c plus a into b plus c minus a by 4bc. Now s will be a plus b plus c by 2 and s minus a will be b plus c minus a by 2. So root over 2s into 2s minus 2a by 4bc. So the formula will become cos a by 2 is equal to root over s into s minus a by bc. So this is an important formula for cos a by 2. Like cosine rule is for cos a and this is for cos a by 2. Similarly, 1 minus 2 sin square a by 2 is b square plus c square minus a square by 2bc. So sin a by 2, 1 minus b square plus c square minus a square by 2bc. So this is root over a square minus b minus c whole square by 4bc. So this is root over a plus b minus c into a minus b plus c by 4bc. So this you can write it as 2s minus 2c and this you can write it as 2s minus 2b by 4bc. So it will come root over s minus b into s minus c by bc. So sin a by 2, the formula will be root over s minus b into s minus c by bc. So this is the formula of sin a by 2. So we have got cos a by 2, we have got sin a by 2. So obviously if I want tan a by 2, I just have to divide them. Okay, I know sin a by 2, I know cos a by 2, so if I want tan a by 2, I just have to divide them. So tan a by 2 is root over s minus b into s minus c by s into s minus a. Now this tan a by 2 formula, if you multiply above and below with root over s into s minus a, then you will get root over s into s minus a into s minus b into s minus c by s into s minus a. So that is area of triangle by s into s minus a. Similarly, cot a by 2, it will be cot a by 2, it will be s into s minus a by area of triangle. Okay, so tan a by 2 is area of triangle by s into s minus a, and cot a by 2 will be s into s minus a by area of triangle. So these are the formulas for sin a by 2, cos a by 2, tan a by 2 and cot a by 2. Okay. Okay, so all of you know that area of a triangle is half BC sin A. So sin A is 2 sin A by 2 cos A by 2. So BC into root over s minus b into s minus c by BC into root over s into s minus a by BC. So root over s into s minus a into s minus b into s minus c. So this is the famous Heron's formula proof. Okay. So area of triangle is half BC sin A. So sin A is 2 sin A by 2 cos A by 2. So sin A by 2 write the formula, cos A by 2 write the formula. So this is the proof of the very well known Heron's formula. Now area of a triangle is half BC sin A. So instead of sin A you write A by 2R. So area of a triangle is half BC into A by 2R. So the area of the triangle is coming ABC by 4R. Right? So the area of the triangle is ABC by 4R. So R will be ABC by 4 times area of the triangle. So area of triangle is ABC by 4R. So R will be ABC by 4 times area of triangle. So this is the circumradius. Now suppose there is a triangle and I have drawn an in circle. So the radius of the in circle is called in radius. So there are 3 triangles. So first one will be half R into A, second half R into B, third half R into C. So total area will be half R into A plus B plus C is equal to A. But A plus B plus C by 2 is semi-perimeter. So R into semi-perimeter is equal to A. So R will be area divided by semi-perimeter. So the formula for circumradius is ABC by 4 into A, and the formula for in radius is area by semi-perimeter. Now there is a way to prove by using trigonometric identities, but that proof is not really needed. I'm just telling you the formula. The formula is that small r is 4 into capital R into sin A by 2 into sin B by 2 into sin C by 2. This formula can be proved using trigonometric identities, but that proof is not really important. So small r is 4 capital R into sin A by 2 into sin B by 2 into sin C by 2. Okay, now this capital R is circumradius, small r is in radius. Now there is something called x radius. X radius means radius of the ascribed circle, mane outside the triangle. So for this actually, by the way, for small r there are some more formulas. Small r can also be written as s minus a into tan a by 2 or s minus b into tan b by 2 or s minus c into tan c by 2. So small r can be written as s minus a into tan a by 2 or s minus b into tan b by 2 or s minus c into tan c by 2. These are all alternative formulas of small r. Now regarding the ascribed circle, so R1 is area by S minus A. So this is S tan A by 2, S tan B by 2, S tan C by 2. Okay, so ascribed circle, these are the formulas. Area by S minus A or S tan A by 2 or 4R sin A by 2 cos B by 2 cos C by 2. R2 is area by S minus B or S tan B by 2 or 4R sin B by 2 cos A by 2 cos C by 2. R3 is area by S minus C, S tan C by 2, 4R sin C by 2 cos A by 2 cos B by 2. So these are the formulas of ascribed circle R1, R2 and R3. Okay, now only for a triangle there are some important identities, right? This is only for a triangle. There are some important identities. So sin 2a plus sin 2b plus sin 2c is 4 sin a sin b sin c. So 1 plus cos 2a plus cos 2b plus cos 2c equal to minus 4 cos a cos b cos c. So sin a plus sin b plus sin c is 4 cos a by 2 cos b by 2 cos c by 2. Cos a plus cos b plus cos c is 1 plus 4 sin a by 2 sin b by 2 sin c by 2. So cos square a plus cos square b plus cos square c plus 2 cos a cos b cos c equal to 1. So tan a plus tan b plus tan c is tan a tan b tan c. And number 7, tan a by 2 tan b by 2 plus tan b by 2 tan c by 2 plus tan c by 2 tan a by 2 is 1. So these are some important identities only for a triangle. Okay. So sin 2a plus sin 2b plus sin 2c is 4 sin a sin b sin c. 1 plus cos 2a plus cos 2b plus cos 2c is minus 4 cos a cos b cos c. Sin a plus sin b plus sin c is 4 cos a by 2 cos b by 2 cos c by 2. Cos a plus cos b plus cos c is 1 plus 4 sin a by 2 sin b by 2 sin c by 2. Cos square a plus cos square b plus cos square c plus 2 cos a cos b cos c is 1, and tan a plus tan b plus tan c is tan a tan b tan c. And the last one is tan a by 2 tan b by 2 plus tan b by 2 tan c by 2 plus tan a by 2 tan c by 2 is 1. So due to lack of time, I don't think we can do any sums today, but we have completed all the formulas, every single formula. Like whatever formula is there in this chapter, every formula we have completed, right? Not a single formula is left. Well, maybe we could have done a few sums, but I don't think we have the time for that. So I think we'll end the session and we'll do some other topic the next day. Okay, thank you. I'll quit the meeting now.